All right, here we go. Today we're going to teach you a new formula. I'm just going to show you where that formula comes from really quick. Don't write this down. Yesterday you learned sine of A plus B is equal to what? Tell me. Sine of A cosine of B plus B cosine of A. So here's a question for you. Suppose that it was sine of A plus A. Suppose the angles were the same. It would be sine of A cosine of A plus sine of A cosine of A. What do you notice? Those are the same, right? So you'd have sine of, instead of A plus A, just 2A, right? And then here you would get 2 sine of A cosine of A. So I can take the sum and difference formulas that you got yesterday, which are difficult to prove, and I can actually do very simple and easy proofs. That's a proof, guys. That's a very basic proof, okay? And we can produce all sorts of new formulas. And today we're going to look at that type of formula. Let's write it down. Sine of a double angle 2A is equal to 2 times the sine of A times the cosine of A. I just showed you where that came from. We can do the same type of process and come up with cosine of a double angle as well. Cosine of a double angle, there's actually 3 formulas you can choose from. The first one is cosine squared of A minus sine squared of A. Or you could choose to use this one, 2 cosine squared of A minus 1. Or you could choose the third formula, which is my favorite, 1 minus 2 sine squared of A. Tangent of the double angle is equal to 2 tangent of the angle over 1 minus tangent squared of the angle. And that completes our double angle formulas. Again, if you want to see proofs for any of those, we can sit down after school and go over them together. It's no big deal. We got it written down. Are you ready? This is the problem, a problem that you would get on your test. This is where people write IDK. All right? That's what I get for this one. It says, given that cosecant of x is 2, cosecant is 2, and x is in the second quadrant, find sine of 2x, cosine of 2x, and tangent of 2x. What the heck does that mean? Here's what it means. Don't draw this. Just trying to give you some understanding. We've got an angle. It's in the second quadrant. Okay? You agree that cosine's negative over there? Tangent's negative. Sine's positive. Great. It tells us that cosecant happens to be equal to 2 right there. So if we double that angle, if you double it, what quadrant would you estimate it would be in? Okay, so let's say you double it, you get something in the 4th quadrant. Well, all of a sudden then, what's going to be positive over there? Cosine, and then tangent sine will be negative, right? And some of the values might change. So it's saying, given the green one, what would the black one be? That's what it's wondering. And it's not that bad to figure this out at all. It says, find these 3 things. So we write them down. Sine of 2x, cosine of 2x, tangent of 2x. I have a formula for sine of 2x. What is my formula for sine of 2x? Yep, 2 sine of x, cosine of x. So being the angle is expressed as x, I'm going to use x instead of a. It's just a variable. So if only I knew sine and cosine. Shoot, I wish I knew what sine was. 1/2. How'd you get that? If cosecant of x is equal to 2, then sine is 1/2. So now I need cosine. Shoot, I wish that there was a formula that was really, really important that if I was given sine, I could find cosine. How about this one? Is that one useful? Yeah. Is that one important? Heck yeah. We can use that. If we simply know sine, we can find cosine, correct? Let's go to work. What is sine squared? If sine is a half, what's sine squared? A fourth plus cosine squared is equal to 4 over 4. Now what? Subtract, so I've got cosine squared is equal to 3 over 4. Square root. Cosine of x is equal to plus or minus the root of 3 over 2. Is cosine going to be positive root of 3 over 2 or negative root of 3 over 2? How would we know? It's in the second quadrant. Is cosine positive or negative in the second quadrant? It's negative, so I got negative root of 3 over 2. And if you can do that, the rest of the problem is actually easy. What's 2 times a half? 1 times negative root of 3 over 2. I told you for cosine of 2x, I like to use this formula. 1 minus 2 sine squared of x. Part of the reason I like to use that is because I already know what sine squared is. We already determined sine squared right in our work over there. What is sine squared? A fourth. What's 2 times a fourth? So I get 1 minus a half. What's 1 minus a half? A half. And everybody's looking at the tangent formula like, oh crap. I don't actually use that tangent formula. I say if we want to figure out tangent of 2a, we use a different formula. We use sine of 2a over cosine of 2a. Would you agree that that's better? So let's use that. What is sine of 2a? Negative root of 3 over 2. What's cosine? 1/2. How do I divide those? Multiply by the reciprocal, and you notice that those cancel, and I get negative root of 3. And that's done. And I don't think that that's that bad. Go get some brain food, come on back smarter, and we'll have a great rest of our lesson. All right, second type of problem is these lowering powers formulas. So if you check out your sheet, just to make sure that we're all paying attention, we just went over the green one, these double angle formulas. That's what we just did. And now we're going to go over our power reducing formulas. So you gotta know where to find stuff on the test. Okay, this is the sheet that I give to you. So power reducing formulas. Very useful in calculus to know power reducing formulas. Not as much calculus 1, but definitely in calculus 2. Sometimes people have this idea that your calculus 2 professor will actually like review all the trig with you. No. Grab this sheet, make sure you take it with you in college so you know what to do, okay? It's a good thing to hang on to this sheet. Lowering powers formula. Sine squared of x is equal to the following. 1 minus cosine of 2x all over 2. Let's see what happened. And I can prove this formula for you. You stop by my room afterwards. It takes about a minute and a half. It's very easy. Sine squared becomes, instead of a squared, we just have first degree, don't we? So it's, see how it lowered the power? It lowered the degree. And then we have cosine that popped up. Cosine squared of x actually reduces to 1 plus cosine of 2x over 2. Pretty similar, isn't it? Yeah. And then finally, tangent squared of x happens to be 1 divided by the other, which is 1 minus cosine of 2x over 1 plus cosine of 2x. So there we have those three. All right, example number 3. Rewrite the following expressions in terms of first power of cosine. Notice the directions. It says first power and it says cosine. So right now, this is run on 2 levels. I have squareds and I have a sine. We got to get rid of that. Anybody know what I want to plug in for sine squared? 1 minus cosine of 2x over 2 times, what do I plug in for cosine squared? Awesome. Let's multiply the top. 1 times 1, 1. 1 times cosine of 2x, cosine of 2x. Negative cosine of 2x times 1, negative cosine of 2x. And finally, negative cosine of 2x times positive cosine of 2x, a negative cosine squared of 2x. A lot of times people want something to happen to that angle, like cosine of 2x times cosine of 2x. People want to get like 4x squared out of that. That's not the case. And I'll make the argument right now. Sine of x times sine of x, you guys all tell me it's sine squared of x, right? You don't do anything to the angle, do you? No. All right. We multiply the denominators. Multiply the denominators, you get 4. What do you notice about the numerator? Cancels, and that's awesome. It's Christmas. 1 minus cosine squared of 2x all over 4. The directions are rewrite the following expressions in terms of first power cosine. Did we get it in terms of cosine? Yes, awesome. This part is taken care of. Is it all to the first power? No, it's not. And we don't have a formula. You see, our formula says if you have cosine squared, it becomes 1 plus cosine 2x over 2. Here you got cosine squared of 2x. That's different, isn't it? So what do you do if you don't have a formula? You make up a formula. So let's make up a formula. Cosine squared of 2x. I mean, if it's cosine squared of 2x, that looks pretty similar to cosine squared of x, right? So if we make a new formula, it should probably look pretty similar, right? I mean, they should look, pretty much the same. So we'll put a 1, we'll put a plus, we'll put a cosine, we'll put it over 2. But I noticed that in this formula, what changed was the x, right? Here I had an x, here I have a 2x. So watch what happens. As you go from here to here, what happens to the angle? It doubles. So as I go from here to here, the angle should double. Hey, cool, we got a new formula. That is not voodoo math. I didn't make it up. 1 minus, what do I put in place of cosine squared of 2x? Yeah, so I put 1 plus cosine of 4x over 2 all over 4. I definitely got rid of the sine, right? We only have cosine, right? And I definitely have first power, don't I? It's just now we got a complex fraction going on, don't we? We don't leave complex fractions, so let's kind of work through that. Instead of 1, we'll write it as 2 over 2. So I've got 2 minus 1 is 1. I'm going to distribute that subtraction sign through. And when I distribute that subtraction sign through, I get negative cosine of 4x over, what's the denominator here? 2 over 4 over 1. Now what? Multiply by the reciprocal. And we get 1 minus cosine of 4x all over 8. Okay, last one. We're going to run right up to the bell, okay? See if we can get it. Sine to the fourth. What should I write it as? Good. Sine squared times sine squared. What do I put in the place of sine squared? 1 minus cosine of 2x over 2. 1 minus cosine of 2x over 2. Multiply that guy out. What do you get? Ooh, I got to FOIL it, so I got to take negative cosine of 2x times 1 and negative cosine of 2x times 1. I'm going to have negative 2 cosine of 2x in the middle. And then the last term is going to be positive cosine squared of 2x. Over what? 4. Great. I got it to cosine, but this is squared. What do I put in its place? 1 plus cosine of 4x over 2. We got 1 minute. 1 minus 2 cosine of 2x plus that thing, 1 plus cosine of 4x over 2. All over 4. Awesome. I did my work. I just now have a complex fraction, right? So I should change the 1 to what? 2 over 2 minus 4 cosine of 2x over 2 plus 1 plus cosine of 4x over 2 all over 4. Are there any terms that we can combine? 2 and 1 make 3. Staying with me, bell's going to go. We're almost done. Minus 4 cosine of 2x plus cosine of 4x all over what? Yeah, it'll be over 2 and then over 4. So they'll all be over 8. Nice work. Stay on top of that homework, folks. If you need help, I'm here after school today, Thursday. Come see me. I'd love to be able to work with you.